Evaluation of the myo signals must be completed prior to definitive prosthesis manufacture and fitting. Preliminary evaluation will help determine the ideal electrode position and gain, as well as the most appropriate switching mode. The following components are necessary for a successful evaluation of the myo signals: a PC with installed Paula software, the Exchange MyoBoy including electrode adapter and USB cable, 2 Myobock electrodes, an electrode armband for placement of the electrodes on the residual limb, a small flathead screwdriver for adjusting the electrode position, and a pen to mark the electrode position on the skin. Begin by connecting the components. Start Paula software. Connect the MyoBoy to the electrode adapter. Next, connect both electrodes to the connectors in the center of the electrode adapter. Check the gain and set it to 5. Connect the MyoBoy to the PC using the USB cable. This will enable you to see the electrode signals represented on the screen by the software. Switch on the MyoBoy and test the connection by touching the contacts of both electrodes. Your preparation is now complete. Before starting the myo test, explain the process to the user and ensure they are comfortable. A careful, accurate evaluation of the myo signal and the corresponding adjustment is essential. This will affect the definitive fitting and final result. Begin by examining the musculature and skin condition of the residual limb. Pay special attention to scars, bony prominences, and painful or sensitive areas. Test the range of motion at the elbow and forearm. The electrode positions can now be defined. Where possible, the electrodes should be positioned on intact skin areas. To determine the electrode position, examine the muscle activity of the residual limb. Activation of the residual limb musculature is achieved by phantom hand movements. Demonstrate to the user the phantom movement to be performed: wrist flexion and extension. The fingers remain relaxed throughout the movement. The user performs this movement bilaterally. Suggesting the user close their eyes may help them to visualize the movement. Proceed through the process for each individual muscle group. Here the process is demonstrated for the forearm flexors of a transradial fitting. While contracting the flexor muscles, palpate the area of the highest muscle belly to determine the preliminary electrode position. Place the electrode lengthwise along the muscle on the highest muscle belly. The electrode can initially be held in place by hand. To define the optimal electrode position, check the myo signal with Paula software. The exact position of the strongest myo signal can be determined by moving the electrode around the region and testing the signal at each location. Mark the optimal electrode position on the skin. Determine the optimal electrode position on the antagonist muscle group, in this example the forearm extensors, by performing the same process as described above. Fix both electrodes on the marked positions with the electrode's armband. For reliable prosthesis control, 2 well-separated myo signals are required. Signal separation must therefore be tested with Paula software after determining the electrode positions. The aim is to generate 2 well-separated myo signals when the user is contracting with different strengths. In the case of insufficient signal separation, or overlapping signals, repeat the process for determining the electrode position. After both electrode positions have been determined, individually adjust both EMG signals for proportional prosthetic control. A good myosignal should be held with a moderate muscle tension of about 80% for 2 seconds, in the range of the high threshold. Furthermore, the signal should be varied in the white area between on and the high threshold to guarantee proportional force and speed control. If the myosignal tends to be too weak, increase the gain. If the myosignal tends to be too strong, decrease the gain. Once both myosignals are properly defined, select the switching mode. Switching modes are necessary to switch between the hand function and wrist rotation. The recommended switching modes are 4-channel control or co-contraction. The principle of 4-channel control is to generate 4 control signals out of the existing 2 electrode signals through different types of muscle signals. Through an initial slowly increasing muscle signal, the hand opens or closes as long as the signal is maintained above the on threshold. Through an initial quickly increasing muscle signal, the hand supinates or pronates as long as the signal is maintained above the on threshold. The significant advantage of this switching mode is the direct and fast control of each of the 4 prosthesis movements. This provides the highest functionality for the user. The principle of co-contraction is to enable the use of hand function or rotation by an additional control signal. A co-contraction is a simultaneous short tension and then immediate relaxation of both muscle groups. When hand function is activated by a co-contraction, the hand opens with a red signal and closes with a blue signal. When rotation is activated by a co-contraction, the red signal rotates the hand outwards and the blue signal rotates the hand inwards. Phantom movements which may aid visualization of co-contraction are making a fist, spreading fingers outwards, snapping fingers. In general, movements can be carried out with greater speed by using 4-channel control than by using co-contraction. However, especially in the initial stages of use, co-contraction provides safer prosthesis control due to separation of hand function and rotation. Once both myosignals have been evaluated and the switching method is defined, check and train the settings with the myosimulation in Paula software. This ensures that the user can control the prosthesis independently and reliably in everyday life with the selected adjustments. For optimal training effect, instruct the user to perform individual prosthetic movements, for example, open hand, close hand, co-contraction, pronation, and supination. To check the reliability of the movements, vary the speed and the order. By completing the evaluation, you have laid the foundations for a successful prosthesis fitting and use. Finally, transfer the determined electrode positions and the gain, as well as the switching mode, to the definitive prosthesis.